Here's problem 1020. A uniform rod is 2 meters long. The rod is pivoted about a horizontal frictionless pin through one end. The rod is released from rest at the horizontal position. What is the angular acceleration of the rod at the instant the rod makes an angle of 70 degrees with the horizontal? Since they're asking for angular acceleration, we need to think in terms of torque on this problem. If it were asking for angular velocity, then we would think in terms of energy. But here we need to think about torque. So we have a pivot point and we have a rod that has fallen to a position that is 70 degrees below the horizontal. And since we're thinking of torque, we want to think in terms of all the forces and moment arms that might be acting on the rod. In fact, in this case, there's really only one external force, and that is gravity. It's acting on the center of mass of the rod, and it's pulling straight down towards the center of the earth with a force of mg. So we're kind of interested in the moment arm for that force. In other words, what is the distance between its line of action and the pivot, which would be this distance d right here. If I looked at that triangle, with the hypotenuse of that triangle being 1 meter, since we're going to the halfway point on the rod, that distance d is going to equal 1 meter times the cosine of 70 degrees. And what is the cosine of 70? 0.342. So d is 0.342 meters. Good to know. And that torque that we're looking at is force times moment arm, F times d, and that's going to be equal to mgd. If that is the only torque acting on this rod, and it seems to be the only one that's causing the rotation, then that would be responsible for the net torque, which is the moment of inertia times the angular acceleration. So, if we set these two torques equal, we have the moment of inertia times angular acceleration is equal to force times moment arm, which is equal to mg times d. Solving this for angular acceleration, we have angular acceleration would be mgd divided by the moment of inertia. Recall that the moment of inertia of a rod pivoted about its end is equal to 1/3 ml squared. So this angular acceleration will be equal to mgd over 1/3 ml squared. M's will cancel out, and we'll get that the angular acceleration is equal to 3gd over L squared. Sounds good? Well, 3 times g, 9.8. Our moment arm was 0.342, and our L is 2 meters, so that's squared. So what do we get? 3 times 9.8 times 0.342 divided by 2 squared, 2.51 radians per second squared. So that is our angular acceleration at that point, 70 degrees below the horizontal point, 2.51 radians per second squared. Answer.